Question number 5. From the diagram, this diagram, EF is a chord of a circle whose arc is ECF. If CD bisects EF perpendicularly at D, for a line to bisect another line perpendicularly, there are two things involved. One is that that line has divided that other line into two equal parts and has created an angle of 90 degrees on both sides. So if they say that CD bisects EF, this line CD bisects EF perpendicularly at D, that means CD has divided EF into two equal parts, ED and DE. And that's why you see these two strokes here. It's showing you that FD is equal to DE. And that same line that bisected it has created an angle of 90 degrees here, both sides. That is the meaning of a line bisecting another one perpendicularly. Now we are asked to calculate the radius of the circle which arc ECF is part of. That is if, that's supposed to be if here. EF is 12 cm. Let me repeat the question. The radius, calculate the radius of the circle which arc ECF is part of. If EF is 12 centimeters. If EF is 12 centimeters. This arc is part of a circle. Had it been that the circle is completed in this way, where O is the center of the circle. Now, if they say you should calculate the radius of this circle is CO and the same thing as OF and the same thing as OE. Both OE, OF, and OC are both the radius of the circle. Now look at this. Let's take OF as the radius. If you look at this triangle, it's covered that this triangle is also a right-angled triangle. Then if this is a right-angled triangle, this side FO is the hypotenuse, whereas DO and DF are the other sides. Now look closely. If the question has given us that CD is 2 cm, whereas CO is the radius of the triangle, so the radius of the circle. Now, OF squared, which is the hypotenuse of triangle ODF, is equal to OD squared plus DF squared. This is Pythagoras theorem. The Pythagoras theorem supports what we have written down. Now, OF squared is the radius. So, the radius squared is equal to OD is the radius minus 2. The distance from here to here is equal to the distance from here to here minus the distance from here to here. That was why I said OD, which we have OD squared, is equal to the radius, which is OC, minus DC, which is 2. So instead of writing OD squared that we do not know its value, let's write radius minus 2 squared. It is representing OD squared. I hope you understand me. Now plus, here they said that EF is 12 centimeters and CD has perpendicularly bisected the EF. That means DF is 6, while DE is 6. So instead of writing DF squared, let's write 6 squared. Expand this. Arrow squared will be equal to, what this means is arrow minus 2 into arrow minus 2. Remember our quadratic equation. Plus 36. 6 times 6, which is 6 squared. This question has occurred severally. In my experience when I was a classroom teacher, I discovered that this question has appeared in GCE, it has appeared in JAMB, it has appeared in WAEC. It is only because of the adoption of this quadratic idea. I believe that is why the examiners kept repeating it. Okay, let's simplify the brackets, or let's remove this bracket. You're going to discover that arrow squared is going to be, arrow times r will give you arrow squared. Arrow times minus 2 will give you minus 2r. Minus 2 times r will give you minus 2r. Minus 2 times minus 2 will give you plus 4. Then bring down plus 36. Collect like terms. Arrow squared is going to be equal to, we have arrow squared minus 2r minus 2r will give you minus 4r. Then plus, add this to this. 4 plus 36 will give you 40. Now try to collect like terms now. Take arrow squared to this side of the equation. You are going to have arrow squared minus arrow squared on the left hand side of the equation. It's going to be minus 4r plus 40. This will cancel this and leave you with only 0 here. So we have 0 is equal to minus 4r plus 40. Take minus 4r to the left hand side of the equation. You are going to have plus 4r and it's going to be equal to 40, which is at the right hand side of the equation. If you divide both sides by 4, you'll be left with only r on the left hand side, and on the right hand side you have 40 divided by 4. And 40 divided by 4, which is 10 centimeters, becomes the value of r, which question number A. Remember, this is question number A. Let's take the big part of the question. The big part of the question says we should calculate the area of the sector OEC. I remember when we were small, 1979, 1980, 1981, when I was still a schoolboy. That time we used to wear 5 very thick knicker inside before we now put the knicker of our school uniform on top of the 5, making it 6 knicker. Then if we do small bad things or we fail mathematics, our teacher will flog us. When he will be flogging us, or when she will be flogging us, we will be pretending as if it's too painful. I will be screaming and crying. But when he or she finishes, I will pass around and we'll do it like this. You wouldn't know that inside our knicker is 5 pieces of knicker to make the buttocks very thick. Even if you like, flog us 100. It doesn't enter. It's audacious. So what reminded me that OEC, there's one construction company in our village then that graded our village road. That construction company, the name is OEC, Ozubo Engineering Company. Okay, that's by the way. So they said we should calculate the area of the sector OEC if O is the center of the circle that EF ECF is part of. OEC, the sector. To calculate the area is very simple. The area of a sector is calculated by theta all over 360 times pi r squared. Now, what is going to be our theta? If you look at this triangle, you discover that this is a right-angled triangle. EO is the hypotenuse. ED is one of the sides, and DO is one of the sides. So, in finding the value of theta, the sine of this angle, EOD, sine angle EOD, where the angle is at O, is equal to opposite, which is ED, divided by adjacent, which is, divided by hypotenuse. Sine, opposite of a hypotenuse, which is EO. So sine of EOD, this angle, is equal to the opposite ED divided by the hypotenuse. Opposite of a hypotenuse is sine. Now, the sine of EOD is ED, which is 6 cm. Remember that EF is 12 and it is perpendicularly bisected by CD. So we're giving it 6. So we have 6 all over EO. EO is the radius of the circle, which we calculated in equation number A to be 10. That means sine EOD is 0.6. If sine EOD is 0.6, that means EOD as an angle will be equal to, go to your 4-figure table, open to sines of angles. I have taught how to do this in the junior classes, SS1, SS2. I know you in SS3 now, you're supposed to know what we're talking about. Just open to sines of angles. You can find it in page 20/21. Look for 0.6. Yes, I could see 0.6. What I saw is 0.6004. That is the closest number to 0.6. And I found it at horizontally to the left 36 and vertically up 0.9. That means this angle is 36.9 degrees. And this 36.9 degrees is the value of our theta now. So our theta, or area of sector OEC, which the question is asking for, is going to be 36.9 all over 360 times pi is 22 all over 7. It's a standard value, times r. The r we calculated to be 10 times 10 squared all over 1. So we're going to have 36.9 times 22. I'm multiplying the numerator together times 100. 10 squared is 100. All over 360 times 70. I told you should memorize this. 2520. That's the value. Now let's multiply out. 81,180. Now divided by 2520. 2,520. It's given me 32.2142 or 2143 in 4 decimal places. And this is going to be in centimeter squared. That is the area of that sector OEC Question number 6 says, the diagram shows a quadrant of a circle of radius r found inside a square of side 10 cm. This is the quadrant. Quadrant means 1/4 of a circle found inside a square of side 10 centimeters. Assuming it was calculated, this should be it, not if. Assuming it was calculated that the area of the quadrant, the area of this quadrant, is half of the area of the square. The area of the square. The area of the quadrant is half the area of the square. Find the value of r. It's a very simple question, although it looks big. The area of the quadrant, the theta that you are going to use in theta over 360 times pi r squared, that theta is going to be 90, because the angle of the whole circle is 360, and the quadrant is 1/4 of a circle. That means the angle of the quadrant is 360 divided by 4, which will give you 90. So area of the quadrant is 90 over 360 times pi r squared. Pi is 22 all over 7 times r squared all over 1. Remember, it is this arrow that we are looking for. The question said is equal to half of the area of the square. The area of the square is length times breadth, which is 10 times 10. So it's going to be equal to half of 10 times 10. Because 10 times 10 is the area of the square, of which the quadrant is half of. We have established our equation. So let's simplify out. This will give you 1/4. Because 90 divided 7 will give you 1. 90 divided 360 will give you 4. Then times 22 over 7 times r squared all over 1. It's now going to be equal to 100. 10 times 10 times 1 is 100 divided by 2. You can still simplify more. 2 divided this is 2. Divide 22 is 11. So you're going to have 11 r squared in the numerator. 11 times r squared all over 2 times 7 is 14. It's going to be equal to 2 divide 100 is going to give you 50 all over 1. At this juncture, you can cross multiply. 11 r squared times 1 will give you 11 r squared. It's going to be equal to 50 times 14. 14 times 50 is giving us 700. If you divide both sides by 11, you'll be left with only r squared on the left-hand side of the equation, and on the right-hand side, you have 700 all over 11. If you divide 700 by 11, you have that r squared is equal to 63.636363. You're correct. 6364 in 4 decimal places. If that is the case, if you take the square root of both sides, the square root of r squared is r, then you find the square root of 63.6364. Whatever it gives you is the value of r. It's giving me 7.9772 in 4 decimal places, centimeters. That means the R is 7.9772 centimeters. Now I want us to go into discussion on spheres and hemispheres. A sphere is a circular structure that the circular form is not perfect. Just like the shape of an egg, that is the shape of a sphere. A hemisphere is half of a sphere. So whenever you hear the word sphere and hemisphere, they are coming from the same lodge. Okay, the first question I want us to take says that a sphere has a diameter of 16 centimeters. We should calculate A, its volume, B, its surface area. The volume of a sphere is calculated by the formula 4 divided by 3 pi r cubed. I repeat, the volume of a sphere of any shape in the whole world is calculated with this formula 4 divided by 3 times pi r cubed. So question number A. The volume of the sphere there is given by 4 divided by 3 pi r cubed. That is the formula for finding the volume of a sphere. This will give us 4 all over 3 times pi remains 22 all over 7. R is half of diameter. If diameter is 16 cm, that means R is 8 cm. So we have 8 cubed all over 1. This is going to give us 4 times 22 and multiplying together the whole numerators times 8 cubed all over 3 times 7 will give you 21. So let's use our calculator. 8 cubed means 8 times 8 times 8. 8 times 8 times 8, then times 22 times 4 is giving us 45,056. 45,056 all over 21. So let's divide by 21. 2,145.5 is giving me 2,145.5 cm cubed, and that is the volume of that sphere. It says we should calculate the surface area of that sphere that has diameter 16 centimeters. The formula for the surface area of a sphere is different from the formula for its volume. The formula for the volume is 4 over 3 pi r cubed. But the formula for surface area is 4 pi r squared. So the formula for surface area of a sphere, surface area of a sphere is given by 4 pi r squared. 4 times 22 all over 7. That's 4 times 4 over 1. Then times r. The diameter is 16. R will be 8. 8 squared all over 1. Let's multiply out. 64. That is 8 squared times 22 times 4. 5,632. Then divided by 7. It's giving me 804.57 cm squared. So this is the surface area of that sphere, which question number B has asked us to calculate. Question number 2 says a spherical shaped metal 6 cm in diameter was melted and poured into balls shaped containers. Ball shaped containers of diameter 0.5 cm each. Now the question is, how many of the containers will it fill? The first thing you do is calculate the volume of the ball shaped metal. Then calculate the volume of the volume of the spherical shaped metal that was melted. Now you calculate the volume of the ball containers. Divide the volume of the spherical shaped metal that was melted by the volume of one of the ball shaped containers. Whatever it gives you is the number of the containers that the melted spherical shaped metal can fill up. Just very simple. So volume of melted metal is given by 4 divided by 3 pi r cube, which will give us 4 all over 3 times 22 all over 7 times, they say that the diameter of the spherical shaped metal is 6 cm. That means its radius is 3. So you're going to have 3 cube all over 1. This will give us 4 times 22 times 3 times 3 is 9. 9 times 3 is 27. So instead of 3 cube, we have 27. All over 3 times 7 is 21. Times 1 will remain 21. So let's use our calculator to multiply out now. 4 times 22 will give you 88. Then 88 times 27 is giving us 2,376. Now divided by 21. Divided by 21 is giving us 113.1429 in 4 decimal places. Now volume of container, one of the container, will be calculated from the same formula for volume of sphere, but it says ball shape, that means it's a sphere. 4 over 3 pi r cube. This will give us 4 all over 3 times 22 all over 7 times. They said each of the containers has a diameter of 0.5. That means the radius is going to be 0.5 divided by 2. Sorry, the radius is going to be 0.5 divided by 2, which will give us 0.25 cube all over 1. We're going to have 4 times 22. I'm multiplying the numerator together times. Let's find the cube of 0.25. 0.25 times 0.25 times 0.25. It's giving us 0.01563 in 1, 2, 3, 4, 5 decimal places. All these things divided by 3 times 7 is 21. We're going to have, let's multiply out now. 88, 4 times 22 is 88. So 88 times 0.01563 is giving us 1.37544. Now divided by 21. Divided by 21, you are going to have 0.065 in 1, 2, 3, 4 decimal places. So this is the volume of one of the container to which the melted spherically shaped metal was poured into. The question asks how many of these containers could the melted metal fill. Now you have discovered the volume of the melted metal and discovered the volume of one of the containers. Use the volume of one of the containers to divide the volume of the melted metal. Whatever it gives you is the number of containers it will fill. That will bring us to number of containers. Number of containers we're going to be 113.1429 divided by 0.0655. So let's divide out. 113.1429 divided by 0.0655 is giving us 1,727.4 of the ball-shaped containers. This is rounded up to 1 decimal place. So that means 1,727.4 of the ball-shaped containers will be filled up by that spherically shaped metal that was melted. Question number 3 says, assuming the volume of a sphere was found after calculation to be 1,000 cm cube, that we should calculate A, the radius of the sphere, B, the surface area of the sphere. The volume has been calculated. That means 4 all over 3 pi r cube will be equal to that volume that was calculated, 1,000 cm cube. This is question A. Now, what this means is 4 pi r cube divided by 3 is now equal to 1,000 divided by 1. If you cross multiply, you discover that 4 pi r cube, 4 pi r cube times 1 will give you 4 pi r cube. Will be equal to 3 times 1,000, which will give you 3,000. We are trying to make r cube the subject formula because the question says we should find r, which is the radius of the sphere. So r cube is going to be equal to, if you divide both sides by 4 pi, you're going to have on the right side of the equation 3,000 divided by 4 pi. Now, our root cube is going to be, let's simplify this. What I'm going to do is, you know that pi is 22 divided by 7. So write 22 divided by 7. It will give you a value. Then multiply it to 4. It's giving me 12.5714287. But in this case, although it is not very advisable to approximate numbers until the last stage of working, but in practice, if you do it, it is not too bad. The only difference between what is supposed to be the correct answer and your answer will not be less than 1 or will not be more than 1. So the degree of accuracy should dance around 1 figure. And when that is done, you are still correct. Now, what we're going to have here is 3,000 divided by 12.5714. No, if I continue to write now, 2857 is going to be very boring. So let's leave it at these 4 decimal places. 4714. Now, if you divide out, you find out that our root cube is going to be 3,000 divided by 12.5714, which will give you 238.6369. Also in 4 decimal places. Only R, which is the radius the question is asking for, is going to be the cube root of what you have here. The cube root of 238.6369. So let's find the cube root of this. Whatever it gives us is the value of R. It's giving us 6.2 in 1 decimal place. So the value of the radius the question is asking is 6.2 centimeters. The B part of the question says we should find the surface area of the sphere. The formula for surface area of a sphere is 4 pi r squared. It's going to give us 4 all over 1 times 22 all over 7 times r. The r we have found in equation A, which is 6.2. We have 6.2 squared all over 1. If you simplify this, whatever it gives you is the surface area of the sphere in question. We are having 382.72. Now divided by 7. 1 times 1, 7 times 1 is 7. So divide this by 7. It's giving me 483.2457.143. But let's leave it at the 4th decimal place. So this is going to be centimeter squared. This is the surface area of that sphere that the question has for us. Question number 4 is taking us to hemisphere. I want to explain to you what my teacher told me long ago, precisely in early 80s. Yes, early 80s. That was the primary school. He told me that a sphere is a round-shaped object that resembles the egg of a tolo tolo. I hope you know what tolo tolo is. Let me just help you. A tolo tolo is a turkey. Have you seen the egg of a turkey before? It has this shape. Don't mind my drawing, no. I'm not a good artist, but I know how to use drawings to explain things to people. I got it very, very right. This is the egg of a turkey. So you told me that a sphere is something like this. Then that a hemisphere is like cutting this egg of a tolo tolo into two equal parts, either latitudinally or longitudinally. For instance, if you cut it this way, you find out that you're going to have something like this. And something like this. If the volume of this complete sphere now, we have been calculating it from 4 all over 3 pi r cube. Now, the hemisphere, which is half of it, is going to be the same 4 all over 3 pi r cube divided by 2. As simple as that. If you know what this formula means is 4 pi r cube all over 3. So when you say divided by 2 all over 1, you are saying 4 pi r cube all over 3 times 1 all over 2. Remember, when you change the sign of divisibility to that of multiplicity, you invert the fraction that follows. So if this is the case, if you multiply out the numerators, 4 pi r cube times 1 will give you 4 pi r cube. 4 pi r cube. Then it will now be all over 3 times 2, which is 6. So if you see us using this formula or something like this, 4 all over 6 pi r cube as the formula for finding the volume of a hemisphere, it did not come from the Pluto, neither did it come from the sun. It came from practical mathematics. So this is the formula we use in finding the volume of a hemisphere, because a hemisphere is half of a sphere. So I'm going to clean up now and apply this formula. So now let's go to the question. The question said I should calculate the volume and surface area of a hemisphere of radius 2 centimeters. Let's first of all calculate the volume. The formula for finding the volume, as I had illustrated to you, is 4 all over 6 pi r cube. This is going to give us 4 all over 6 times 22 all over 7, that is pi, times the radius of the hemisphere is 2. So we have 2 cubed all over 1. If we simplify this, whatever it gives us is the volume of the hemisphere the question is asking for. So let's start multiplying. 2 cubed is 8. So we have 8 times 4 times 22 is 88. 8 times 88 will give us 704. So we have 704 divided by 6 times 7 is 42. So we have 42. Now divide 704 by 42. It's given me 16.7619 centimeter cube. this I have rounded up to 4 decimal places. So the volume of that hemisphere is 16.7619. Now let me continue the illustration by my teacher, because also the day he illustrated how this formula came by, he also illustrated how the formula for the surface area of a hemisphere came by. So in that case, he told me that this hemisphere complete has the formula of surface area of 4 pi r squared. Then the hemisphere, the surface area for a hemisphere is not this 4 pi r squared divided by 2, just as you had in the volume. That is going to be the surface area for this half, which will give you 4 pi r squared all over 2, plus the surface area of the complete circle, the face of the hemisphere, which is pi r squared. That was what he told me. Pi r squared. This is pi. So it is half of the area of the hemisphere plus, because as you have cut it, you have exposed it to a circle. You know, if you cut this hemisphere at the center, you are going to get a perfect circle. So the illustration there is the area of half of the sphere plus the area of the exposed circle. You and I know that the area of a circle is calculated from pi r squared. Then the area of a sphere is calculated by 4 pi r squared. That means the area of half of that hemisphere, which is going to be 4 pi r squared divided by 2, then plus the area of the exposed circle, will now give you the area or surface area of the hemisphere. And that's exactly what you have here. This means if you cancel this, you have 1, cancel this, you have 2. To give us 2 pi r squared plus pi r squared. If you add this to this, you're going to have 3 pi r squared. So this 3 pi r squared is the formula for finding the surface area of a hemisphere. Just like that of the volume. It did not come from the Jupiter. Neither did it come from the moon. It came from practical mathematics. That is why you should love mathematics. Everything about it is in it. Is buried in it. It's just for you to practice. By the time you practice, and that is why the concept of this DVD, God dropped it in me, and I'm referring it to you. By the time you study with this DVD, all you need to know in all the classes, why won't you make it? Why you are not making it is at times the syllabuses are not being covered in your school. All the things you needed to know are not being taught to you. So when you are not taught a particular thing, are you a spirit to know it? When you are not told anything, one philosopher said that when you are not informed, you are disformed. And that is true. When you are not taught what you should know, how are you going to know it? Are you a babalawo? You are not a spirit, you are a human being. You can only remember what you have seen, what you have heard, what you have tasted, what you have felt, what that has touched your sense organs. Otherwise, you don't have a link to it because you have not felt it, you have not heard it, you have not tasted it, you have not seen it, you have not smelt it. That's by the way. So I'm going to clean up now and begin to use 3 pi r squared for finding the surface area of a hemisphere. We're going to start immediately. So our hemisphere now, we have the surface area from 3 pi r squared, which is going to give us 3 all over 1 times 22 all over 7. I'm splitting the formula now. Then times r, which is 2. We're going to have 2 squared all over 1. If you multiply out this, whatever you get is the surface area of the hemisphere that the question has. So let's multiply out, giving us 264. Then divided by 7. Whatever it gives you is the surface area of that hemisphere. It's giving me 37.7143 in 3 decimal places. Remember, this is going to be centimeter squared because we're talking of area. And that has brought us to the end of that question number 4.